Hi, I'm Dr. Mehboob, MD Ophthalmology from AIMS New Delhi, and I am here to discuss the important investigations that is ERG, electroretinogram, and electrooculogram, the basics and the different diseases which causes the abnormality of these things. Okay, without wasting time, let's start. So what is an electroretinogram? It is actually the electrical potential, I mean electrical standing potential of the retina. That is, it measures the retinal electrical activity when stimulated by the light of adequate intensity. Basically, which ions plays an important role, that is the influx and efflux of the sodium and the potassium ion is actually responsible of these things. Okay, now, this is the graph, the basic graph of the electroretinogram. So, obviously, you put the electrodes over the certain areas, and then you measure this electroretinogram. This is beyond the scope of the big of this topic to make you understand where the electrode is put. Okay, just understand this graph. So we have this one. At this point, the stimulus is given at this point. Now, after the stimulus is given, now see, after the stimulus is given, the phase is silent before any activity starts. Then the A wave starts. So from the time of the stimulus given to the start of the A wave, this is called the latency. This is called the latency period. Okay. Now this A wave comes and then there is a B wave, that is peak, and then it goes down in the C wave, a slight negative. So why does the A wave is formed? It is because of the influx of the obviously sodium ion. So basically at first there is a hyperpolarization. So just remember what cells is actually responsible for this is the photoreceptor rods and the cones responsible for this A wave, right? Now coming to, then there is the interaction. See, this is the photoreceptors, the interaction with the Muller cells and the bipolar cells. Then this forms the B wave, and then there is a slight negative. This is the depolarization state, and then there is a slight negativity. This C is from the retinal pigment epithelium. This is very important, that the cells you need to know. How to remember this? See, B wave, bipolar cells, B for B, B wave, and B for bipolar. This is it. And there's an interaction between the bipolar and the Muller cells is actually responsible for this peak of the B wave, depolarization and the peak, right? Why this implicit time, what is the from the time of the stimulus is given and the peak of the B wave is reached, this time is called implicit time. Why I am just giving you that this latency and the implicit time? Because it is this point, it is this parameters measured in the electroretinogram. Okay, so that's why it's very important to understand this. Okay, coming to the important thing is that uh, see this photo I have just made for completion point of view, nothing to be remembered, this complex photo. Okay, this is rod like B wave only, combined rod and cones both, oscillatory phenomena, cone. If you want to segregate only cone function, then you have to highlight this your by the 30 hertz to 50 hertz intensity wala frequency se you have to highlight the, I mean illuminate the retina. So this is for the cone only, so this is not for U label. Coming to the important thing, that there are certain types of the ERG like full field ERG where the whole of the retina is being measured. This can be scotopic. After 30 minutes of dark adaptation, you measure the measure this ERG and you get the rod function. After 15 to 20 minutes of patient keeping the patient in the bright light, you measure the cone function, that is the photopic ERG. There are other ERG also, that is multifocal ERG, where the 3D view of this is takes place. This based on, like suppose if this is a retina, okay, of the right eye, then this area, obviously this area is having the high density of the rods and the cones. So to stimulate this area, you need only very lower amount of intensity, but the amount of the photoreceptors, cones and rod is very low in the periphery. So to illuminate this area, you need very high intensity. Based on this fact, this 3D picture of the, see, the intensity is low, the intensity amplitude is high. Based on this picture, this 3D dimensional photo is being made, and this pic is being read. Okay, now focal ERG is only for the macular diseases. So what, this is just for the completion. What is important to know here, that abnormal ERG is present in retinitis pigmentosa, cone dystrophy, cone and dot dystrophy, that is congenital stationary night blindness, choroideremia. Choroideremia is X-linked recessive condition. This can be asked in the examination. So this is about the ERG. Moving to this electrooculogram. Electrooculogram actually if suppose this is the RP cells, okay, and this is the apical part and this is the basolateral part, okay, basolateral part. So this is the difference. Electrooculogram measure the standing potential, and standing potential is the difference of the potential of here and this area of the RP. Okay, standing potential, this is actually being recorded here, but for the sake of convenience we have write that it is the electrooculogram measures the standing potential between the electrically positive cornea and electrically negative back of the eye. This is a simplification form, but actually we are measuring this one. Got it? Now it measures the activity of RP, and obviously the photoreceptor is embedded here. Now that's why photoreceptor. So any diseases beyond or proximal to the photoreceptor will be having a normal EOG, but does not cause any changes in the EOG. Now what is I am to say, what I have to say, that this EOG, this standing potential, I mean this standing potential keeps, EOG ka standing potential keeps on changing. Since it keeps on changing it every time, so it is not possible to measure the standing potential at certain point of time and then say that this, the patient is having this disease. So we need some certain parameter. So what we actually do, after keeping the patient in the dark for 30 minutes, we measure a standing potential, that gives the dark trough, and then we keep the patient in the light condition in 10 to 15 minutes, and then we measure the light peak. The ratio of this light peak and the dark trough gives a figure, which we already know that conventionally we called it Arden index. Okay, however this is not the exact true term that has been proven nowadays, but you just can say this Arden index. If it is more than 185% or more than 1.85 or equal to 1.85, it is normal, but if it is less than that, it is subnormal. So what are the condition where the abnormal EOG is found? Best vital in macular dystrophy, Stargardt's macular dystrophy, retinitis pigmentosa, acquired corneal dystrophy, choroideremia, and Garrett atrophy. And there are so many examples, but these are the important ones that I have highlighted here. In best vitelliform disease, it is around 125% or 1.25. So you just need to know about these things. So this is about the ERG and EOG. Okay, and in the next class we will be studying about the VEP and USG. Okay, thank you.